The challenge we face, we have all these equations, but the challenge really is when we have a frustum, how the heck do we figure out the various segments? So let's just take a quick peek at that. Let's go ahead and imagine that this top one is the washer. And we're going to have several cases that we need to think about. Let's consider the case first where the second plate is above the midpoint of the frustum. And we have a washer on the bottom as well. So we have 1, 2, 3, 4, 5 segments, just like I said before. In order for us to calculate the K's for each of these things, I have also said that we need to know the elastic modulus, the top diameter, and the thickness of each. So I need to know for washer 1, or for segment 1, I need to know E1, D1, and T1. For 2, E2, D2, T2. For 3, likewise. So that's the stuff that we need to know. So we need to create a table of those things, and that's what we end up doing in Excel. And that's how we can solve the problem. So there's 2 conditions that we care about. The first condition is if the upper plate is above the geometric midpoint of the frustum, which leaves another segment in there. Or the other condition that we have to think about is if the upper plate extends, so we have the washer, and then imagine the upper plate comes here, and then the frustum geometric midpoint is there. So we still have 1, 2, 3, 4, 5 segments, all of which have K's that we have to figure out. But we have to consider how we're going to measure the thickness of these things. Now, the most important step, no matter what you do, I'm going to go ahead and redraw this now, where the midpoint of the upper plate is above the geometric midpoint of the frustum. And in the other case, we have that the midpoint of the upper plate is below the geometric midpoint of the frustum. So we have 5 segments in each case. We just have different thicknesses that we need to worry about. And the other thing that we need always is we need to know D1, that's the diameter of that top plate. We need to know D2, that's the starting diameter of the second segment. I need to know D3, which is the starting diameter of segment 3. I need to know D4, and I need to know D5. Likewise, all the T's. Easiest T's are the washers, okay? So T1 equals T5 equals T1 equals T5 equals the thickness of the washer. So those are pretty straightforward. The next trick is we have to sort out how we're going to find if L over 2 is half the grip length, we have to figure out the thicknesses of everything. So there are going to be conditional statements that occur. So what we first do is we say, all right, if L over 2 is greater than T1 plus the thickness of the top plate, L over 2 extends beyond the reach of the top plate, then the thickness of the second layer is just equal to the top plate thickness. If, however, if L over 2 is less than T1 plus the thickness of the top plate, as it is in this case, so this is the top plate thickness, this is the thickness of the washer, which is T1. So if that's the case, so if L over 2 is greater than T1 plus the thickness of the plate, then T2 is just equal to the plate. Else, T2 is equal to the grip half length minus T1. So that is this condition here. So there's your if-then statement for assigning the thickness. So we get the thicknesses, and we're going to do that. We're going to put our segment list here. We're going to put our thicknesses. So our segment is 1, 2, 3, 4, and 5. Our thicknesses are T1, T2, T3, T4, and T5. And we have to find the D's associated with those. Once we have the D's and the T's, then life gets easier. So we need to find D1, D2, D3, D4, and D5. We've already said that D1 is equal to D5, which is equal to 1.5 times the diameter of the bolt. Same thing if the washer wasn't there, it'd be applying load over the same diameter to the plate. So we figured out how to find T1 and T2 pretty easily. We know how to find T5. We know how to find D1 and D5. So then what is D2? Once we have T D2 is just the diameter at the next step down. That's at the beginning of segment 2. D2 is just going to be equal to D1 plus twice the thickness of layer T1 times the tangent of the angle alpha. Pretty straightforward. Now, next up, we got to figure out what is the thickness. We've got thickness of layer 1, thickness of layer 2. What is the thickness of layer 3? So if you look at this drawing up here, if the L/2 exceeds the thickness of the plate in the washer, then so this condition up here, if L/2 is greater than the thickness of the washer layer plus the thickness of the plate, T1 plus the thickness of the plate. So if L/2 exceeds that, then T3 is just equal to L/2 minus T1 minus T plate. It leaves that distance right here. That's L/2 minus those thicknesses. What about this one right here? If T3, if L/2 is less than T1 plus T plate, T3 is going to be equal to T1 plus T plate minus L/2. So there are your conditions. Those are your logical conditions. So we now have T3. T4 is going to be, right, so we now have to figure out also what D3 would be. We figured out what D1 and D2 were. This is the D2 equation here. Under the conditions here, if L/2 is greater than the thickness of the washer and the top plate, then D3 just be equal to D2 plus twice the thickness of the top plate, that's T2 times tan alpha. That's pretty straightforward. So that's true under this condition. If L/2 is less than T1 plus T plate. So under the conditions where L/2 is less than T1 plus T plate, we'll be looking at this circumstance right here. And we're then trying to find this segment, that's the third segment, and we need this diameter here. That's going to be our D3. Okay, so under these conditions here, D3 would simply be, well, we go all the way to where we were before. We go to D2 plus twice T2 tan alpha minus twice T3 tan alpha. Now life is easy. Okay, life is easy because D5 is equal to 1.5D, and D4, which is just above it, would be equal to 1.5D plus twice T5 tan alpha. So that's pretty straightforward. So now we know we have D1, D2, D3, we have D4, we have, the only thing left for us is T4. T4 would just be equal to the grip minus T1 minus T2 minus T3 minus T5. So that gives us T4. It doesn't matter which side you happen to be on in this particular frustum. So now we have everything we need and we can just go to the spreadsheet.